I think levels are good. Hello. Hopefully y'all can hear me. Yeah, I think so. Cool. Welcome back. How you doing? Glad to be back. I'm Agent Ultra. If this is your first time tuning in, welcome to the stream. On here, I build stuff with functional programming mostly in a language called Haskell. Maybe we'll expand our repertoire some other time or someday in the future, but that's mostly what I do. And for the past little while, I've been working on building a multiplayer game in Haskell. Kind of an old school design called a multi-user dungeon, or MUD. This classic kind of multiplayer game is the predecessor to the modern day MMOs, and the MMOs of yore as well, because it comes all the way back from probably as early as the mid or early 80s. And yeah, I used to play these a lot when I was a kid, and I thought it'd be a nice, quick project. Well, maybe not so quick, but a nice little project for us to hack on in Haskell to show its networking and concurrency support, which is just excellent. And maybe have a little fun too. Might be we get this game engine far enough and we build enough of a game around it that we could mess around with it on the stream and do some fun stuff with that. Of course, the kinds of projects I do on this stream are mainly just for fun and learning, so if there is something you're interested in that you want to see me attempt in Haskell, maybe you don't believe that you can write real software in Haskell, or what have you, drop me a line, let me know. And we'll give it a shot. Anyhoozle, for now, let's get into the code, shall we? So last time I ran the stream, I was sick last week, so it was a couple weeks ago. We got Lua interop working. So the idea for this server is that we're going to have kind of a generic, well, the server itself is going to be written in Haskell, right? And it's going to run all the networking code, the anything that interface with the operating system, all the persistence, things like that. And it's going to call into some user code. The user code is going to be written in Lua. And the idea is that you can define your entities and instantiate things and run game logic in Lua. I'm calling into the engine as you need. That's written in Haskell. And that sort of stuff. So we kind of got we tested out the waters with Lua interop last week. Or last week I did the stream. And we're going to continue on in that rough area this week. And kind of get forward so that we can get to like a minimum viable server that people can log into and do stuff with. Maybe chat to each other or like move around from room to room. Something like that that you would normally do in a MUD. And then we'll see how far we can get there. So let's see. I'm gonna probably implement the simulation tick, the main loop. All right, we got some Lua code running. I want to kind of run the simulation loop in a proper tick sort of thing, so we can start getting that going at a reasonable rate. That sort of thing. So first, we're going to have to keep track of our... Yeah, we're going to have to implement the loop. So we're going to go to the server state, and we're going to have a time accumulator. So basically, we're going to run this a certain number of ticks per second, right? And each tick is going to do all the updates it needs to do on all of the entities that are awaiting updates, and send out all the output to all the users. Or no, it's going to call the user code basically to do all the updates, and then it's going to send all the updates that need to be sent out. It's going to flush all the output to the users, and then we call the next tick. All right. I kind of have some ideas about the general structure of how I want to do things. with this, I think will work well. But yeah, first things first, we're gonna have the server state time accumulator. Yeah, we'll call it sim time milliseconds. Accumulator milliseconds. And we'll do that as an int. Yeah. So the idea is that we will, every time we go into the simulation loop here, we're going to get a time delta based off the start time. And then we are going to accumulate a certain number of milliseconds to our accumulator. And once we're over a certain limit, then we're going to do our tick and reset the time accumulator. So we'll have server state sim time rate. This is going to be how many milliseconds to accumulate. Or tick. And so if you set it to like 100, that'll be 10 ticks per second. And this will be our delta time accumulator. So we should just call it that. Okay. I'm gonna be more clear. Okay, I think that's all we'll need for that. Let's make sure I got chat up. What's up, chat? If it's your first time tuning in, welcome. Thank you. I love teaching people stuff, so if there's anything you want to stop and like dig into further, let me know. Or if you want to show me your projects, that's cool too. You know, I like the distractions of diversions and helping people learn more Haskell if they're curious. Okay. So yeah, now that we have that, we need the start time, the server start time as well to calculate our delta time. And that'll come from our system time. I'm going to make it an int for now, even though it might be a slightly different type. And so I have to add those here to our empty server state. Pop down here. Not main path, we need start time. And that's 0, even though we gotta set that, we gotta initialize it to something. I'm gonna hard code it for now to 100. Probably want to be able to set this. And set that to 0. Yeah, on that. And we're all good there. Okay. We could put it as a param. This is almost not like empty server state anymore. It's going to be like an initializer. But But it is in IO. We could actually do that here. Their start time. And then I should call it init. I think system time. Do time diffs. It's from the old time library. On the time library. I don't know if we need this. So this library is a little bit, might be a little bit overkill. I thought there was one in base. What is it? I'm having a brain fart on it. What is it called? Epoch. Just look at base. System. Go. CPU time. I don't know about this. Maybe we do need the time library. That would be unfortunate. Timeout. No, not quite. Okay. Maybe we do. Okay. Well, the time library is pretty extensive. Alright, let's do it. Let's go in Cabal. And we're going to add that as a dependency. Time. And probably 1.15. Oh, just 1.15. Okay, let's get our builder, GHCID running. .15 is too much. There we go, 1.14. That will do, pig. That will do. Okay, so then we should be able to import that to get our system time. Okay, data.time.clock.system. we can get it. Let's get current time, get system time. Okay, I just want that as a number. 64. Alrighty then. And we have to import in 64. From data.int. We'll get the start time. System seconds. Okay, and we'll create a little commit for that. And once again, I have to reset up my Emacs environment. Which I did try to do with stream. Change the owner, there we go. And all that. Okay, back to where we were. Look at it. Added time and server time variables. Okay, and now we can go to the simulation. We should be able to do that same import. Pop it in there. Okay, so in the simulation now we can get our delta time. So we're gonna start with getting our system times we did before. Target system time. And maybe I'll go right to an N64 for that, as long as I've got... yeah, IO, okay, yeah. Do, and system seconds. GHCID to start up again. We have to lift IO that, of course. More like that. And then once we have the current time in N64, we can get our delta time. That will be from our server state, so we're going to have to ask for that. Start time. Thing start time. And we need control.monad reader for that function. Come on, Dad. And I called it something else. Called it this. And I need that in scope in order for it to not be a hole. There we go. Okay. So now DT is going to be our current time. It's going to be the bigger number. Minus our start time. Okay. And now we can accumulate that into accumulator and do our checks. So we'll get our accumulated time. Delta time accumulated milliseconds. Barrel. Okay, so on this iteration, when our accumulated time plus our current delta time is greater than our sim tick rate, or our sim time rate, we want to do stuff. Otherwise, yeah, we have 2 branches there. Yeah. We could do when accumulated time plus DT is greater than server state sim time rate. Do stuff. And finally, we want to accumulate that into, or the delta time into our accumulated time. Modify the state. Load the main module, start. This stuff we probably should put in a tick function, I guess. Oh, which we kind of did. Yeah, here. So I'm gonna move that down. Cut this. Yep. All of that. We'll do the little P call inside that when block. We need when, which comes from control.monad. And modify state is not the function I was looking for. That's probably from here. Modify strict. Alright, it's just modify tick. And this takes a function that modifies the state, which we're going to do. So we need that in scope. We got name clashes with Lua. We'll import Lua qualified. I think I don't have a post pot if I got qualified. Lua. Tick is going to take a Lua.state. It's going to be a Lua.luap call. And with new state, it's going to be Lua. It's also going to be Lua. And oh no, sorry, with string, C string comes from us. A different library. And that's the one right there. No margs. That's also from Lua. Okay, and then we just have to implement our accumulate DT. It's going to be 64 server state to server state. We need data.int. Server state takes a parameter. Oh no. We don't really care about it, I don't think. And our time rate is just an int. We could make it an int 64 as well to get rid of that type error. Not a biggie. And the accumulator needs to be, okay, yeah. Is greater than, right, and start time. I feel like I should be able to clean this up, but we're just going to go with it. Same time rate. Okay, and then we want an IO unit. We're getting an IO status code here. Oh, tick is pure IO. Oops. We don't have the reader here. So we can't do asks there. We have to pass it right in. Tick here, unless we make tick an IO, a Bakamud function. And is there a reason why we couldn't? Shouldn't? Let's just go with it. Oh, we need to lift IO. Okay, that might be an issue. The coloring here is going to be a little bit tricky. Okay, yeah, on line 32 here. Okay. So Haskell's telling us here that we want this to be an IO because this lift IO block, Lua's with new state is an IO action. And so everything in the tick here also has to be within IO. Our Bakamud server has IO at its base, but it is a monad unto itself that doesn't run under IO. That could be a bit of a problem for the design of this thing, because we want... Tick is going to be doing... Might be doing stuff with the server state. After running user code, updating things, possibly. I'm wondering if maybe we should move this Lua initialization stuff closer to the edge, closer to where we start up the server. That will help that. Yeah, because we definitely want to be updating the server state here for the tick count, stuff like that. See, well, hacky, there might be a way to hack that. It's kind of gross, but we have a way to run a Bakamud server. We can get the current state of this Bakamud server and then run it, use the run function with that state inside tick. I don't know that that would work in preserving the state of the server properly with everything else that interacts with it inside the Bakamud server. Is it with a value? Might be a little bit weird. What else could we do here? We could update all the tick state here outside in simulation, maybe. But it's not the one looping. So we use... Okay, anything... I'm wondering, okay, maybe I need to look at the Lua library here. So if we can create that reference to the state once, but if we just want to make calls into IO within a Bakamud, that's fine. That works. So if there's a way I can instantiate the state with a Lua state that I can pass around, that would work. It represents the state of the whole Lua interpreter. And it's all available through this structure. So it's... Yeah. So I don't want to do with state. I want to now just do open state, for example, and closed state myself. Okay, that's the close. Okay, destroy all objects in the given Lua state. Calling the corresponding garbage collection meta methods. Freeze dynamic memory used by the state. Yeah, and then we'll probably need to close states as soon as they're not needed. Okay. Thread. We need a state first. How do I create a state without the with state function? That's all I want. maybe we can do it with new state just in the main loop, and we just put in a TVAR in our state. Okay. We are gonna have to do that before we do this. Let's stash this stuff. I'll call it. I'll call it ticker. And we'll start moving this stuff out first. See if we can't do that. Okay, so let's go to let's say server. Let's go even lower. Here. Run Bakamud server. It's a reader T. Okay, good to know. That's right. And it's a reader T, not a state. Okay, because we're going to put all of the stuff that we want to change on the server inside a reader T and like wrap them in TVAR and stuff. Okay, that's right. Yes. It's been a couple of weeks. Sorry, getting caught up again. Reading your own code. Okay, so what we're going to do then is go to the state. Yeah, we'll put the... Kill that buffer. Do that again. Okay, there we go. Sort of. Yeah, kind of. Alright. We'll put the Lua interpreter state in here. I'll put that here. We'll qualify it. Well, no. We can probably just put it in Lua. Just need the state type there. And put it here. Lua interpreter state. Put it in a TVAR of state. We could maybe even do it right here. Now empty will definitely become more of an init kind of thing. So I'll have to create a new empty TVAR to hold it. T-bar IO. And we'll return T-bar of A, which would be our state. Lua state T-bar. Selling scammy behavior. Selling followers is scammy behavior. Don't do it. Been reported. Okay, Lua state T-bar. New T-bar IO. It'll be goes to with new state. And all we want to do is put it in there. Although new TVRIO wants to take the A in. We might have to do it this way. Bump that over. And pump that here. We're going to call it right there. Perfect. US state T-bar. And there. There. Okay. So I'm going to also rename this to init while I'm here. And then that means in the main, where we actually call it, like that. Okay, so then in our simulation part, here, we no longer call with new state here, we already have a state. And we need to not only ask for it, but we need to unwrap it. So we can go atomically. This might get a little tricky actually, because atomically is going to do this in a STM transaction. And we don't want multiple threads concurrently accessing, concurrently reading and using the state. So we'll have to be careful. But like, if simulation is the only thing using this interpreter, that should be fine. But maybe I'm just getting a little ahead of myself. But it's something we'll have to think about and look for. Needs to be lift diode. Okay, so we can get rid of this and remove all of this. Now we have to lift IO these actions here. Okay, that all compiles, so it should work just as before. So if this is your first time tuning in, you haven't seen us run the server yet. This is what it's going to look like. Not super impressive at the moment, but it's a start. Bakamud. While that's compiling, let's just run a client. So it's just like a generic MUD client, multiplexes input and output for you, and stuff like that. So once the server is up, we should be able to connect to it and try this out. And it should just load this, call this Lua function that we have set up here, this Lua code. And the Lua code we have at the moment is main.lua. Should just print hello from Lua. Ah, we've got a seg fault in the linker here. Interesting. Well, that's unexpected. Could cause that sometimes. Let's temporarily stash that, build it again. Okay, that's what it normally does. Hello from Lua, yeah. Connect to it. Printing out the Lua code, prints out hello from Lua. Okay. Interesting. So something about the code I just wrote, it's causing a seg fault in the link. It looks like in the link step. If we're importing foreign code, sometimes, maybe. It could be the way... It could be the we're just doing something too funky here. Especially with server initialization. Lua new state here with new Lua state. Oh, so when this function returns, it's going to close the state. This is why I want the state. Yeah, it's not going to work. Dang. Yeah, it closes on return. Okay, so that's probably what's causing... I don't know why it's causing the seg fault on the link time. That seems like a runtime kind of thing, but... that could be it. If I debug.traceM here and say like, hello. Oh, it might not be segfaulting in the link. It might be segfaulting at runtime, actually, just as I imagine. Because, yeah, link time, that wouldn't make sense. Or qualified. Okay, yeah. The segfault is at runtime, yeah. Okay. Yeah, it's probably at runtime. I imagine when we actually go to execute the Lua code with the interpreter state this way that we've done this. Probably here somewhere. For some debugging here. We'll do some good old-fashioned debugging here. Okay, can we get to... there? Oh. Okay, so this makes sense. The with function is probably closing the state of the interpreter when it returns, because that's what it does, and now we have an invalid interpreter reference we're hanging on to here that we're trying to call Lua L open libs on, and so it's throwing it's segfaulting. It's throwing some kind of like unrecoverable runtime exception thing here. Okay, so the Lua library, so if I just create a state, it's just a void pointer. Is there a way for me to initialize it at least or something? Initialize or start or open. There's function pointers. No, not quite. Let's dig into the internals of this with new state. See if we can't figure it out from there. HS Lua L. That's what we want. Lua ersatz auxiliary. Okay, that is exported. Is this module exported? Oh, there it is. Okay, perfect. Let's go. Lua ersatz auxiliary. Okay, so now we're gonna get rid of this. We'll de-indent this part. Get a Lua state from this this function. Yeah, come on, get to me. Give it to me. That. And give it that, like that, and then we can get the state that way. Okay, if we get it this way, and run the Bakamud server. I did mean this. Auxiliary. Okay, I don't know how to spell. Okay, cool. Sweet. All right, looks like it compiles is running. We have not crashed. Something going on with Guild Client here, but whatever. Quit. Okay. That's good. That solves that problem. Let's get rid of the debug trace stuff. Okay, so now that that's moved up, we should be able to do the rest of the stuff that we originally wanted to do, so I'm going to commit that. So when applied, this change will update init server state. Added Lua state. Changed. renamed empty server state to init server state. There we go. Okay, let's see if I can apply that ticker code cleanly. Slight differences here. Both of those will be fine. Probably over that one. That. Oh, they're just slightly too different. I think I want variant A there. Create the main module. TR. Get the L from that. Okay. Yeah, I think that's fine. Okay, not compiling yet, so let's just get GHCID running and get that fixed. Fix that. Okay, and then okay, with C string still coloring us with IO here. Okay, so we could get that result here instead. And we should be good. We have to lift IO this. Yeah, that's not modify. We have to do something else to collect to get the delta time. Thread delay, we don't need concurrent there. State, that's right. Okay, that's fine, that's not defined for now. Okay. So then, let's go back, let's revisit the server state. Yeah, we're going to change the accumulator. This is no longer, it's a reader, it's not a state monad. So anything we want to mutate, we have to like wrap up in the thing that we can mutate. Do we need an M-bar, T-bar on it? We don't need a full TM bar. Yeah, T-bar is probably fine. So here, this has to be initialized as a T-bar. We call it delta accumulator T-bar. vacuum time T-bar. I'm going to peek at it. Left to lift IO. There. Okay. We can't that, we check it, and we still need to accumulate before we tick. We're going to accumulate the delta time. And this can be an N64 to Bakamud server. Yeah, I'm going to put the string down. Okay, put our hole there. Put our DT in, so there we go, Bakamud server. And now we're going to comically modify T-bar. Modify T-bar straight. That's a T-bar A. Oh, I have to do that. Why don't I pass it in? Second argument, maybe? There we go. Okay. All right, so kind of works. Get that staged. Ready to commit for that. And we're going to be modifying simulation tick. accumulate delta time. Okay. So now this code should be at the start time when we started the server, the time rate, so how frequently we want to run ticks, get the current time, and the accumulated delta time so far, which we read from our TVAR. So we calculate our delta time as the current time minus the start time. How much time since... Oh, no, that's going to constantly get bigger and bigger and bigger. This is not the right formula. What am I thinking? We need the delta time since the last time we ran. Yeah, because we only want to accumulate, like, this is going to loop as quick as possible, like some number of milliseconds. We just want to accumulate those into that accumulator. Right. Alright, whereas this formula here is going to give us an ever-increasing slice of time. Since the start of the server, basically. So what we want is the last time that we ran through the loop. Instead of start time, we'll call it last time. And it's okay to do that from here in init state to be the start of the start time of the server, but we're going to have to update that as well. So we're going to have to wrap that in a TVAR. I call it last time now, so start time. Then let's get GHCID running, of course. Right, wrap that in a TVAR. Start time. Actually, that. Not start time we want last time. before we tick, we update the last time. We could pass in the T-bar. We're gonna have to go here because we're gonna have to do the atomically block at the last. We're gonna get the update time here. Get the system time now. And then we can modify the T-bar, atomically modify the T-bar here. We don't even care what it is. Actually, if we don't care what it is, can we just just write the T-bar? Yeah, we'll just write the T-bar instead of modifying it. Wait, what? Oh, brr. Oh, jeez. Yeah. Pass that in. Last time T-bar. System time. Oh, yeah. Because we want the seconds thing, right? System seconds. That's why. Okie doke. That is okay, better. From Lua. Good stuff. Now we should be seeing this repeatedly. I'm just gonna put like a footster len here. Curious why it's only running once. or getting nothing at all. Let's do it with debug. Let's put it up here. Oh, we got a few ticks. Okay. Maybe our rate is just not set right. Oh, yeah. That makes sense. If this is in seconds, I think I was expecting milliseconds. For the server tick rate. But if we're calculating them in terms of seconds in our delta, and we're accumulating 100 seconds before we tick. Yeah, can I get a faster, can I get millisecond granularity on system time? That's the question. I can get nanoseconds. Well, that's sub-second. That's too much. State. I bring this down to 1 second. We see it a lot. Because I need that up here. Tick, hello from the wet tick, and let's output the value of accumulated time. Tick 2. Oh wait, we accumulate the delta time. Right, here. We have to update. We have to reset the delta time. That's right. Okay. All right. Reset the accumulated time. That's why. Set mark time. Set that accumulated time with all we have to do is tonically rate T-bar. Zero. Doop, 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 doop. Okay, we're going to tick 185 there. Little space here between these. Okay, so let's review a little bit here. Our accumulated time plus our delta time is greater than our time rate, which is right now currently set to 1. We tick. We got hello from Lila. And then we reset the accumulated timer, which should set the accumulated timer T-bar to 0. And then apparently this happens again. We get no call to the P call here. Probably something going on with Lua. We should reset the timer again on the accumulated time. So let's add a little bit more bin tick. Tick. So if we run this, we should be seeing lots of these BNN ticks. And then we stop. Oh, is our thread crashed? we're not checking the result of this Lua P call. I comment that out and don't call it at all. See lots of begin end ticks with an occasional tick in between, but if I get rid of those because they're causing a lot of noise, we should just see tick, 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 tick. Okay, we see tick, 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 but we should be seeing more ticks now. Alright, yeah, come on. Is it the pure here? I think so. I could take it out though. Tick 1, I took 184. Tick negative 182. We got 4 ticks now. So somehow we got a negative accumulated time. Okay, that's interesting. How do we get a negative accumulated time? Accumulative time TVAR and a DT. Okay, our DT is a subtraction, so that's possible. Okay, and now it's like every time it gets one of those, it's got to catch up a lot. Yeah, this is not quite right. I'm thinking it maybe we don't use system time at all. And we just have a globally incrementing integer that we increment once we start the server. Something like that. Because it's not quite right. I mean, this should technically work. Well, obviously it doesn't. I'm doing something wrong here in the code, at least. The code is doing something wrong here. We should assume delta time should be a positive number. Well, we will have to solve this another time. We're out of time for the stream tonight, friends. Let's go. Great. This stuff's all in development, so I don't mind committing it in the state it's in. Okay, well, thanks for watching. I'm gonna push this code up. All of the code you've seen tonight for this project is called Bakamud. It's a mud server. Trying to build a mud server here in Haskell. And a mud server is a very old school way of playing games online, like multiplayer online games at the same time. Yeah, we're writing in Haskell. You'll be able to extend and build your own games in this engine with Lua once we're all done. And maybe one day we'll get some, we'll play it on the stream a little bit with you folks. And get some Twitch integrations built in or something for funsies. So if you want to check it out, it's on GitHub. I'm Agent Ultra. It's Agent Ultra Bakamud. So you can give it a star if you like. Follow along with its development. You can also follow me on the socials. I'm on Mastodon on the types.pl server at Agent Ultra there as well. And my website, agentultra.com, has links to pretty much everything, including my YouTube channel where I back up the VODs for this very stream. So if you can't follow along here or you want to catch up on old streams or whatever, I back up my VODs there and you can watch them on my YouTube channel. What else? Declarative.tv, the link above my head, goes to a fun little website some friends have made that are also streamers who stream things in languages like Haskell and other declarative languages like Erlang and so forth. And if you want to find other cool, fun hackers to follow, go to that website. There's also a link to a Discord server where we have a channel for this stream. So if you think of something that you want to ask about, or you just want to hang out with other like-minded folks, that's the place to be. And get the link from declarative.tv. Thanks again for tuning in. It's been a pleasure. We've got a few viewers tonight, so let's go find someone to raid. And we'll see you on the other side. Raid. Another game developer doing some Blender stuff. Let's go. Thanks for tuning in. We'll see you soon. Take care.